Good morning. So today's class we will see about asynchronous sequential circuits. So in this asynchronous sequential circuits, as we know, we have two types of sequential circuits. One is synchronous sequential circuits, another one is asynchronous sequential circuits. In this, we will see about asynchronous. Why we use asynchronous is asynchronous uses a minimum amount of space and complexity is much higher compared to your synchronous, but it uses speed. It's so speed compared to your synchronous circuits. And in your asynchronous circuits we will be using a small portions in your process. Say if your process having a large if you're having a big process, and each and every process you will be using a synchronous method, but this asynchronous is used in small portions amidst of your synchronous process. Okay, as it is so faster we'll be using like that. And yeah, in terms of your process, say if you are taking banking application, many portions will be used with a synchronous manner, but some portions need not have a synchronous manner. Say some authentication, say some front portion views, some views of your what information from your banking sites that need not be synchronous to your account, so that will be asynchronous. So that's an example of your asynchronous design of circuits. Okay, so let's go into the question here. This is your example question. Okay, so this is one big question which will depict the whole half of the unit in your asynchronous sequential circuits. And here you can see a design of a gated latch circuit with two inputs, G and D. Okay, G is a gate and D is a data, and one input Q. Okay, so you have two inputs and one output. The gated latch is a memory element that accepts D. Okay, so it accepts the value of D when G is equal to 1. So whenever G is 1, you will be accepting some input, either D is equal to 0 or either D is equal to 1, and it retains the value if G goes to 0. Okay, so you can imagine like a gate. When the gate is open, D will be accepting some input, either 0 or 1. Okay, but if you are having a G is equal to 0, you will not accept any input. It means that the previous input is retained throughout the process. Okay, so G, once G is 0, a change in D does not change the value of the output. Okay, so that's there here. Next, for understanding, okay, just I have mentioned this for your understanding. Here, if G is equal to 1, it's already told D accepts some input, say 0 or 1, and output is same as D. Okay, and here you can see D G by output. So I have represented each and every state like this in terms of D, G and output. So I'm telling here if D is equal to 0, so I have mentioned D can be 0 or D can be 1. Here if D is 0 and G is 1, so as I told gate is open, right? So G is 1, my output is whatever the input given to D will be my output. So both are 0 and 0. So, okay, D and output are same when gate is open. So likewise, if B is 1, sorry, in state B, if D is 1, output is also 1 when gate is open. So that's why we write 1 1 by 1. So you can just wonder why we are writing such things like state A, state B. Okay, so for a particular system, everything is represented in terms of a state. Say what kind of a state happens in a starting point, and then pause point, in an ending point, like that. Everything should be represented in terms of a state only. Okay, so we are going to do like that.